Hello and welcome back. In the previous video, we were looking at the sine of a 195 degree angle, which I pulled apart into a 180 degree angle and a 15 degree angle. The reason that I like the 15 degree angle is because it's between 0 and 90, and I think that they're a little bit easier to deal with. So here, after we canceled, so the sine of a 180 degree angle is 0, so this first term vanishes. Then this second term with a cosine of a 180 degree angle, that's just -1. So this simplifies down to negative sine of a 15 degree angle, which a 15 degree angle, that's just the sine of a 45 degree minus 30 degree angle. So we'll use the same trick that we had before with the tangent of a 15 degree angle. Writing 15 degrees is 45 minus 30. And we have our triangles already set up to use. So here, the sine of a difference. So I'm just going to put this negative sign out front with a pretty big parenthesis around it. That's going to be the sine of a 45 degree angle times the cosine of a 30 degree angle minus the sine of the 30 degree angle times the cosine of a 45 degree angle. So ultimately, it's just using the formula that we had before. The sine of a difference of angles is going to be sine of the first, cosine of the second, minus sine of the second, cosine of the first. And then from here, it's just a matter of plugging in everything. So the sine and cosine of a 45 degree angle, the opposite over the hypotenuse, or the adjacent over the hypotenuse, is going to be 1 over the square root of 2. So 1 divided by the square root of 2. And then this guy is also 1 divided by the square root of 2. And then we need the cosine of a 30 degree angle and the sine of a 30 degree angle. So the cosine is going to be the adjacent over the hypotenuse, which is root 3 over 2. And then the sine is going to be the opposite over the adjacent, which is 1 over 2, so that's just 1/2. And then it's just a matter of simplifying this. So this is going to be negative. If I multiply these out, I get root 3 over 2 root 2 minus 1 over 2 root 2. Well, this is handy because fraction with the same common denominator. So it's going to be minus. I've got root 3 minus 1 over 2 root 2. And here we want to be careful because we've ended up with a square root on the bottom. So we'll multiply both the top and the bottom of this fraction by the square root of 2 to get, this will be negative. Root 3 times root 2 is root 6. 1 times root 2 is root 2. And then on the bottom, 2 root 2 root 2. Well, 2 root 2's multiplied together to get 2, so it's going to be 4. So at the end of the day, we have negative root 6 minus root 2 over 4. I hope I haven't made a mistake in there. If you do notice a mistake, let me know, and I will address that. So the next one, so we want to write the following without any angle measures. So for instance, we have this angle in here written in radians, pi thirds. So if we want to get rid of that, we're going to have to try to expand this guy and get rid of those angles that are showing up. So we have a difference of angles here, and we've seen that we can split the sine apart. So this is going to be the sine of x times the cosine of pi thirds minus, we keep the same sign with the sine function, the sine of pi thirds times the cosine of x. So here, what we notice is that we have the cosine of pi thirds and the sine of pi thirds, and pi thirds radians is the same thing as 60 degrees. So we can come up through the triangle that I already drew. This is our 30, 60, 90 triangle, and we need the sine and cosine of a 60-degree angle. So the sine, which is opposite, which is root 3 over the hypotenuse, which is 2. So the sine of a 60-degree angle is going to be root 3 over 2 times the cosine of x. Right? And then here, again, we've got the sine of x, which we can't simplify. We don't know what x is. But the cosine of pi thirds, we can. So the cosine, so here's our 60-degree angle. The side adjacent is 1 divided by 2. The hypotenuse is 1/2. So then we can simplify this. Both of these are times 1/2, so I'll just write this over 1/2, and I've got sine x minus root 3 times the cosine of x. And there we go. So we've been able to write this without any explicit angles showing up. This is sine minus root 3 cosine x over 2. And then here's one more. We've got the tangent of theta plus 45 degrees. So again, what we can do is, if I don't want 45 degrees showing up in there, let's just expand this guy. So we have a sum of angles, so we'll just have to use our formula for the tangent function. This is pretty straightforward. It's tangent of the first one plus tangent of the second, all divided by 1 minus tangent of the first times tangent of the second. Again, this is a formula that you can just write down and look up whenever you need it. But a tangent of a 45-degree angle, so let's just redraw our 45-45 triangle. And if we have side lengths of 1, using Pythagorean theorem, we can see that this side will have square root of 2. So the tangent of a 45-degree angle is 1 divided by 1, which is 1. So that for the top, we've got tangent of theta plus 1, all over 1 minus tangent of theta times 1. But tangent theta times 1 is just itself. So we've got a fairly nice formula for tangent of an angle plus 45 degrees. So these are just some ways to use our formulas for the sum and difference of angles. Here we've got a question that looks a lot like one of the ones in the last section as well. So we know the cosine of an angle S, and we have the sine of an angle T, and we know that both of these angles are in quadrant 1. So draw a picture. We've got quadrant 1 is up here. So both of these are going to be acute angles between 0 and 90 degrees. And we want to find the sine of S plus T and the tangent of S plus T. So first and foremost, let's just write down what sine of S plus T is. This is going to be the sine of S times the cosine of T plus the sine of the other one, T, times the cosine of the other one, which is S. So as long as we know the sine of both those angles and the cosine of both those angles, we're good to go. Which we know cosine of one and then sine of the other, so we'll just have to figure both of those out. And luckily, if we know the sine and cosine of both of them, the tangent of any angle is just sine divided by the cosine. So if we know both the sine and cosine of S and T, we know the tangent of it. That's useful. So what about our formula for the tangent of the sum of two angles? Well, it's the tangent of one plus the tangent of the other divided by 1 plus the tangent of one times the tangent of the other. So again, if we know both sine and cosine of S and T, We know tangent of both s and t, so we'd be able to figure this out. So we have all of our ingredients. We just need to find them. I know the cosine of s, and I know the sine of t. What we need to do is find the sine of s and the cosine of t. And I'm going to use my Pythagorean identity here, because we know that sine squared of s plus cosine squared of s is 1. Cosine of s is 4/5. Oh, wait a second. That was cosine of s is 4/5. So sine squared of s, we don't know what that is, but we know that if we add 4/5 squared, we get 1. So sine squared of s is going to be, well, 1 minus 4/5 squared. 4 squared is 16. 5 squared is 25. So I can rewrite 1 as 25 25ths. So this is going to be 9 25ths. And if I want the sine, I'm going to have to take the square root of both sides. So this is going to be the square root of 9 25ths, which the square root of 9 is 3, and the square root of 25 is 5. Easy. The only thing, though, is that if I take the square root of both sides, do I want the positive root or the negative root? So do I want sine of s to be positive, or do I want sine of s to be negative? Well, we're up here in quadrant 1. And is the sign positive or negative in quadrant 1? Well, x is positive, y is positive, and r is going to be positive. So sine, cosine, tangent, everything is positive in tangent 1. So sine of s is going to be positive, and we even know that the cosine of t is also going to be positive, because t is in quadrant 1 as well. Everything's positive in quadrant 1, and we don't have to worry about it. So the sine of s is going to be the positive root of this. It's going to be positive 3/5. So then let's do t as well. Sine squared t, cosine squared t is equal to 1. And we know that the sine squared of t is 5/13 squared, plus cosine squared t is 1. Move that to the other side. So cosine squared t is going to be 1 minus 5 squared is 25. 13 squared is 169. So this would be 169 over 169. I think if I do that correctly, it's going to be 144 over 169. And because I knew what this was going to be when I set it up, when we take the square root of both sides, the square root of 144 is 12, the square root of 169 is 13. And again, we could technically get plus or minus, but we know that we want the positive root, because everything is in quadrant 1. So let's plug and chug. Sine of s plus t. So we want sine of s is 3/5. Cosine of t is 12/13 plus sine of t, which was 5/13, times the cosine of s, which is 4/5. And then multiplying all these together, 5 times 13 should be 65. 3 times 12 is 36. 5 times 4 is 20. And then over 65. So everything simplifies, and this is going to be 56 over 65. Fairly straightforward. And I will plug and chug the tangent in the next video.